The first introduction class will consist of multiple topics, where in which first topic, that's today, this topic we'll be going through what is MongoDB, and the second topic will be understanding why we have to learn MongoDB, and then we'll go through the important features of MongoDB, and then we'll go through the different editions of MongoDB. So let's go ahead. What is MongoDB? In simple words, MongoDB is a document-oriented NoSQL general-purpose database which is designed with flexibility in mind and with high-volume data storage. So this particular line gives us a lot of information about MongoDB. First thing, it is a NoSQL general-purpose database. So NoSQL general purpose database means this particular database can be used for multiple purposes. It's not only for let's say only for the web application, or it is not only for a standalone application. So you can have you can use the MongoDB for different purposes, and it is a NoSQL database. We'll cover what is NoSQL database in the next slide, but for the time being, NoSQL stands for not only SQL. So it is not a relational database actually. And MongoDB is a document oriented. So document is, you can say that it is the data that is you are storing on MongoDB. It is a lowest unit of data that you are storing on MongoDB. You can say that MongoDB document is similar to a raw in RDBMS. And then it is designed for with flexibility, like so it has the flexibility in its design, like for example you can have you don't have to enable the normalization, or the different fields of the different documents in MongoDB can of different fields. So that means there is no rigidity, it is flexible. And then MongoDB is designed to store, any NoSQL database are mainly designed to store high volume of data. There is no exception for MongoDB as well. In that case, MongoDB is designed for high volume of data. MongoDB takes the best of relational database as well as the NoSQL database. You can see that it has the good features of both relational database and NoSQL database. So which means the customer can use MongoDB for almost all classes or almost all types of modern applications. So let it be a asset or transactions compliant database, or let it store weather forecasting, like any kind of application you are looking, you can see that MongoDB can be fit for those applications. And MongoDB stores the data in the form of collections and document. So document is the lowest, you can say that it's the lowest unit by which MongoDB stores the data, which is equivalent like raw in RDBMS. And collection is a set of documents, which means is equivalent to a table in the case of an RDBMS. Okay, what is a NoSQL database? So NoSQL database are non-tabular database, which means it is not falling into the concept of RDBMS standard. So you can typically NoSQL database may not be following a rigid table, but in the case of MongoDB you are creating collections, and in the collections you can create you can specify the fields, and if via application you can maintain a standard of your fields. If you are inserting the data through the application, obviously you will be able to maintain a standard. So that's what I was telling in the previous slide. MongoDB takes the best of relational as well as the NoSQL databases. And the NoSQL stands for not only SQL. So there are certain definitions which say that NoSQL stands for no SQL, and other definitions stands that not only SQL. So which means it is not only through SQL that you will be able to store the data and retrieve data. So so the NoSQL databases does not use SQL. So that is one of the reason it has given the terminology NoSQL, which stands for not only SQL. NoSQL databases provide flexible schema. So why that flexibility is coming is that it is designed for storing a large volume of data. For example, let's assume that your Facebook updates or the reviews of your the e-commerce product. So that's, if you're looking, that is a huge volume of data is coming, right? So to store that huge volume of data, you need a database which can retrieve the data very fast. So NoSQL database are designed for data retrieval, designed for faster data retrieval. So for that, the NoSQL databases are avoiding the normalization. So whenever you are avoiding the normalization, data retrieval becomes much faster. So the use cases of the NoSQL databases will be product catalogs, logs, user interactions, analysis, etc. So these kind of applications are the places where you can use NoSQL databases. So NoSQL database comes into picture around the late 2000, where in which the cost of the storage was dramatically decreased. So who are learned the let's say RDBMS in detail, we would have seen that normalization was one of the reason for we went ahead with the normalization was that avoiding data redundancy. By avoiding data redundancy, we are reducing the cost of the storage. But now the storage becomes very cheaper. So now the applications is not caring about how much data they are storing. Rather, they are really worried about how much faster they can retrieve the data. So there NoSQL plays an important role, where in which NoSQL is designed for high volume of data with faster data retrieval, and for that NoSQL databases avoids normalization. So among the different NoSQL providers, you can say that MongoDB is one of the most established NoSQL database. So if you make a study on the internet, you can see that this is the leading NoSQL database, which is a document-oriented database. So which means that this data is stored in the form of documents. Okay, and NoSQL databases, you can store the data without a schema. We have a concept of dynamic schema, which means it is a flexible schema. You don't have to define the structure of the your row well in before. Like for example, in the case of RDBMS, you first design your table, right, and then you insert the data, and you cannot store any data outside that particular structure. If you wanted to say, for example, you created a table with the person's name, age, phone number. Now the person one person is having more than one phone number, and if you want to store, you cannot store that with the current structure. You have to add one more column to store the second phone number. But NoSQL databases, especially MongoDB, supports that changes dynamically. You don't have to change the structure when you insert the record or when you insert the document. At that time, the new information can be captured. That's why it's known as a dynamic schema or flexible schema. And MongoDB or NoSQL, specifically MongoDB, can store both structured as well as unstructured and semi-structured. Normally, NoSQL databases are invented to store the unstructured and semi-structured data, but in the case of MongoDB, you can store all the three. That you can store the unstructured data, you can store the semi-structured data, and you can store the structured data as well. So now we have a clear understanding about what is a NoSQL database, right? And now we also understood that MongoDB is a leading NoSQL database. Now let's understand some important features of the of MongoDB. Before that, we'll have a quick review or a quick understanding between RDBMS and a NoSQL database. So the first point to be understood that schema. So relational databases follow a rigid schema. That means you must define your table before you start accepting the data. So first you define the table, you designed what is your columns, what type of data types are there, and how many columns are there. Then you create a table. Then you start accepting the data. But in the case of NoSQL databases, you don't have to follow a rigid schema, because they are designed for storing unstructured data and also with the dynamic structure. So which means you can evolve the database structure as you progress. So for example, you start the first document, or in the case of assuming that MongoDB is what we are discussing now. Let's say I have a table or a collection with the name movies. So the first record of my collection, I'm storing the movie name. Okay, so let's say I have, for that particular movie, I have only my movie name. I don't know who's director and which year they have the movie is released. So the first document contains only movie name. The next document I have my the movie name, the director, and the year of the release, and the gross collection. So I have multiple more data. So I can add these fields, or I can create, in other words, I can create those columns while inserting the records or inserting that particular document. So which means I can evolve or I can modify my database structure as and when I am progressing with the data. In the case of the next difference is that the data structure, like say in the case of RDBMS, you define the structure of a table and you specify what is the data type for that particular column. For example, let's say take the phone number. So in the case of phone number, you either define as a character data or you define as a numerical data. So the data what you are inserting will be adjusted or will be updated as per that. But in the case of NoSQL database, each data can be of different format. For example, it can that particular field can store the text type, or it can store the say the number, or in case if you wanted to store something like a graph or key values. So that means there is a wide possibility of the structure of the table or the columns is possible with the NoSQL. And the third concept is or the third important difference is normalization. So the RDBMS uses the normalization to avoid redundancy of the data, or in other words, to avoid the duplication of the data. So all the relational databases avoids the duplication. So you normalize your data so that the duplications are avoided, which means the storage, whatever the data that you are storing, the amount of data storage is reduced. But the downside is that when you wanted to select data, you will be reading from multiple tables, and the multiple tables are joined with the join condition. And the joining multiple tables is a costly activity with respect to RDBMS. So which means the CPU as well as the memory used for retrieving the data is quite high, and that affects the performance of the database. But NoSQL databases focus more on fast data retrieval, and you are storing the data in a non-structured or semi-structured and structured manner. So that means it can retrieve the data much faster, and it is not mandatory that you should be using the normalization. And the next important point is that the scaling. Scaling is the ability of the databases to increase or reduce in size depend on the need. For example, let's assume that there is a holiday sale going on. At that time, obviously the demand for the or the data access will be quite high. The access to the database will be quite high, and at that time we may require more resources to meet with the need of data accessing, right? So at that time you may to give the same response time, we may have to increase the resources, like say you have to increase the number of CPUs or the memory. So in that case, relational databases allows the scaling, but that scaling is mostly vertical. I'm not telling about all the RDBMS vendor. There are certain vendors like Oracle Real Application Cluster support the horizontal scalability as well. But most of the cases where in which it is increasing vertically, that means you will be increasing the number of CPUs, the number of or the amount of memory, etc. So when you increase that, then it is again difficult to reduce in the size. Say after the holiday sales over, when your usage comes to normal, you may want to reduce the or you wanted to reduce in the size, right? So at that time it may not be that practically possible. But in the case of NoSQL databases, it support both vertical and horizontal scaling. In the case of horizontal scaling, what will happen is that you will be distributing the data across different clusters. Say for example, we can enable, in the case of MongoDB, we can enable sharding, where in which the collection, a single collection can be splitted across multiple servers. So that means the data retrieval will be much faster. So NoSQL, different NoSQL vendors are providing different ways of horizontal scaling, and also the vertical scaling, as how we can do it in the case of an RDBMS is possible in the case of NoSQL database as well. Okay, so now we have understood NoSQL databases. We have understood the difference between an RDBMS and a NoSQL database, and also we understood that MongoDB is a leading NoSQL database. So now let's make a deep dive into MongoDB. The first point to be noted is that MongoDB is a document-oriented database, which means the data is stored in the form of document. So, which means the data is flexible. As I mentioned earlier, you can have the different structure for your data. Each record or each document can have different structure. And it's a general purpose NoSQL database, which means there are different NoSQL database designed for a specific purpose. But in the case of MongoDB, you can use MongoDB in almost all the cases. Say, for example, you are using that one for your e-commerce application, or you are you can use MongoDB for some storing some logging information, or like you wanted to store your reviews. So that kind of situation also you can do, and there are certain cases where in which MongoDB is even used for the OLTP transactions as well. And MongoDB is designed for scalability and high availability, which means using certain features like replication, you can make your database highly available. So you will have a primary database and you will have a secondary database. So in case the primary database is not available, the secondary database will work as primary database, so your application can continue. So that way you can enable the high availability. Scalability, as I mentioned in the previous session, you can split your data into different subsets, and each subset can be stored on different server, and that is known as sharding. So by implementing sharding, you can enable the horizontal scalability, and by increasing the memory and the CPUs etc., or the resources of your computing resources, you can enable the vertical scalability as well. And then another important feature we should consider is that MongoDB is available everywhere. You can say that MongoDB is available on-premise. That means you can install MongoDB on the servers on your data center, or if you wanted to quickly implement, you can implement the MongoDB on cloud by using MongoDB Atlas. And then MongoDB RAM supports for the MongoDB to be available on mobile devices. So considering all this thing, you can understand that MongoDB is available for general purpose, and it is available on-premise, cloud, and mobile devices. So with that, MongoDB is using the good features of the RDBMS as well as the good features of NoSQL databases. Now let's understand the two important concepts of MongoDB, that is collection and document. So MongoDB store the data in the form of collection and document. So document store the data in the form of a key value pair. That means you have a field which is also known as which is equivalent like the column in the case of an RDBMS. So in the case of MongoDB, we use the terminology either key or field. And whenever you are storing the data will be stored in the form of a key and a value. So whenever you are inserting some records or some data to MongoDB, you are not going to use the concept like insert into table, then values, etc. That is how normally RDBMS will do, right? Rather, we are passing the name of the field to which you wanted to insert the data and the data. So always you will insert as a pair. So always whenever you are store the data, you will specify to which field the data is going and what is the data. So that way it is very easy to manage. And the third point is that MongoDB does not have any predefined schema, so which means the developer can add the fields or remove the fields as and when required. So maintaining it's very easy. For example, two documents of a single collection can have two different fields. And then collection is a set of documents and certain built-in functions. So which means you have the option of creating a collection. So when you create a collection using a specific method like create collection, you are creating a collection that is an empty collection. That's one method. Second method is that you don't have a collection, but you are inserting the document. Say let's say db dot collection name dot insert. So at that time you are inserting the data and the collection will create implicitly. So that is an implicit creation, or you can say that on the fly creation. So every collection what is created on MongoDB has certain built-in functions or built-in method. For example, count, which is used for counting the number of documents in the collection. So there are certain built-in methods are available. So a collection is consist of the data that is stored as well as the built-in methods or function that is available for the collection. And important point is that you have the option, or MongoDB supports the creating the collection on the fly, or implicit creation of the collection is supported. And the third one is and the last one is that MongoDB support fixed size collection, or also known as capped collection. So there are two types of collection that is available in MongoDB. One is that fixed size collection, or also known as capped collection, and the other one is a non-capped collection. Now the next point is that where all MongoDB can be used. MongoDB can be used as a product catalog for e-commerce application. It can be used as a blog for the content management, and then it can be used as a real-time analysis, and then configuration management, then storing the location-based data, or also known as geospatial data, and then mobile and social networking sites, and loosely coupled object. If your application is a kind of loosely coupled, or you wanted to change the design over time, in that case also you can use MongoDB. So what are the common use cases? The common use cases are mobile applications, real-time analysis, and catalog management, content management are the common, and Internet of Things. These are the common use cases where MongoDB can be used. And then some of the companies who uses MongoDB, this information we can get from MongoDB website itself. If you just search for the clients for MongoDB, you have a list of clients which is available on the MongoDB website. This list is not a complete list. I just selected some of the major clients. So the clients like IBM, Citrix, Twitter, T-Mobile, Syndex, Sony, all these companies are using MongoDB. And we can also say that there is some of the companies are migrating some of their RDBMS databases into MongoDB. So MongoDB has its own space on as a NoSQL database, but since MongoDB contains the good features of an RDBMS as well as a NoSQL, there are certain cases where in which the customers are migrating from an RDBMS to MongoDB. So I hope now you have a clear idea about what is MongoDB and why what is the advantage of MongoDB. In the next class we will see what are the why we should learn MongoDB, and then we will see what are the important features of MongoDB, and then we will see the different editions of MongoDB. So I'll catch you guys in the next class. Before that, thanks for attending this introductory session, and I hope you guys enjoyed the session, and you will seriously consider of learning MongoDB in detail. Thank you.